Right, so the last concept will be on lens. Okay, so there are two types of lens that we need to learn under the O-level or IP syllabus. So the first will be known as your converging lens. The second will be known as your diverging lens. Okay, so first thing first, what is your lens? So lens is actually a transparent, and of course the material can be made of glass or plastic that can converge or diverge light rays. Okay, so there are a few features for a lens. So the very first important will be your optical center. So optical center is just the middle of the lens. Okay, of course the next one will be your principal axis. So principal axis is something like your imaginary line, yeah, so where the focal point will lies on. So the third will be known as your focal point. Yeah, so this one is the most important one, I feel. So focal point is where the light will converge. So the next thing will be known as your focal length. So focal length is the distance between the optical center to the focal point, or to the first focal point. And last but not least is your focal plane. So focal plane is just like a plane passing through the first focal point. Okay, so let's see how light travel after it enters a converging lens and diverging lens. So for converging lens wise, right, the light will converge to a single point. So this is known as your converging lens. And of course, for the diverging lens, the light will diverge. So later we will see how the light diverge. Okay, so let's go through the 5 laws of how light will travel. So the first law is where when the light is parallel to the principal axis, right, the light will then and pass through the first focal point. Okay, so if example your light, right, on the left hand side of the lens is parallel to the principal axis, on the other side of the lens the light will pass through the first focal point. Okay, second will be if the light pass through the optical center, it will not get refracted, or it will not deviate from the original path. Okay, third will be if my on the left hand side of the lens, my light ray and passes through the first focal point like this. So the light ray will instead, right, will travel parallel to the principal axis on the right hand side of the lens. So it's something like for the first and third law, actually they are the same. It's because light is just a reversal. This is known as the principal reversibility of light. Okay, fourth will be if I have 3 light rays, so they are parallel to each other, they will converge to a point on the focal plane. So this is the focal plane. So last but not least, the fifth law will be if my ray, right, from a point of an object, it will converge at the same point of the image. So what do I mean by that? So imagine that we have 4 rays, 4 light ray, right, emitting from the arrowhead of the object. So when the 4 light ray converge on the other side of the lens, this will actually form the arrowhead of the image. Yeah. Okay, then if you look at the first and third light ray, the first and third light ray actually we learn this in our first and second law, because for the first light ray we actually this first light ray is parallel to the principal axis, it will converge to the first focal point. Whereas for the third light ray, right, you pass through the optical center, so there shouldn't be any deviation from the original path. Okay, then for the second light ray, so second light ray is something that there's no law for it, but if we follow the fifth law, we can actually trace the path of the light ray. You just have to make sure that it converge at this point. Then last but not least, the fourth light ray, same thing, we never learn this, but we know that it will meet all the light rays at this part. So that's why I know that this will follow the respective path, right? So these are the fifth laws that you need to take note of. Okay, so next will be drawing the image of the pencil. So for a lens, you will find the image at the other side of the lens. So for example, how do I locate the image of the pencil, very simple. You always draw two light ray. So the two light ray where they converge or they intersect, this is where the image will be formed. So for example, if I draw a first light ray like this, so first light ray is parallel to the principal axis, it will pass through the first focal point. Then the second light ray will pass through the optical center and intersect at this particular point. So this is where the image is formed. So of course you can also draw a third light ray. So third light ray you can draw in this manner. So okay, you can draw, okay, you can pass through the first focal point first. Then after that, you go parallel to the principal axis. So you can see that all the three light ray will intersect at the same point. And these three light ray, where they intersect at the same point, right, the image form is known as the real image because they are all three real light rays. And of course, what is a real image? Real image means it is an image that can be captured on the screen. So real image is an image that can be captured on screen. So that is the definition of a real image. Okay, so the second, third, and of course the fourth, I will let you try on your own. Okay, I just want to talk about the fifth drawing. Okay, so fifth drawing, you notice that the object is now in front of the first focal point. So this will actually form a virtual image. So what is a virtual image? I'll just show you this thing. Okay, so a virtual image is something that we learn right in the chapter of light. So you can see that when my object is in front of the first focal point here, so the light ray will not intersect at any point here. So where will the light ray intersect? The light ray will actually intersect at this particular point. So this, you can see that the two so-called light rays are drawn in dotted line. So this is actually a virtual image. So what is a virtual image? Virtual image means that it's something that cannot be captured on the screen. So if I put a screen on the image, there shouldn't be any image formed or captured on the screen. So that's the meaning of your virtual image. Okay. So yeah. So I hope this clear things up. Okay. The next thing is, I just want to show you this simulation. Okay. So apparently, if I have an object beyond 2f, you can see that the image form is between, on the other side of the lens, is actually between 1f and 2f. And you can see that the characteristic of the image is actually smaller, or what we call diminished. So it's a fanciful word called diminish. Then after that, inverted means upside down. Then last but not least is real. Okay, what if I move the object towards 2f? So you can see that first of all, the image move away from the lens. And after that, and of course you can see that the image, right, is the same size now. So just now is smaller. Now is the same size. So it's also exactly at 2f. So if my object is exactly at 2f, the image will also be at 2f. So next thing is I continue to move forward. Now the image move away from the lens and it become bigger. Then after that I go to 1f. So 1f is where the image will be formed at the infinity. Of course, the image is known as the virtual image. Okay. Then after that I move towards the lens. Okay. Then now on the right hand side of the lens, the light ray will not converge. So it's like, if you look at the right hand side of the lens, right, you'll notice one thing is that the two arrows or the two light rays are like going away from one another. So they are not going to converge at the right hand side. So if I extrapolate the light rays on the left hand side, you can see that the extrapolation of the light rays actually form a virtual image on the left hand side of the lens. So this image is known as your virtual image, and of course it's upright and magnified. So this is known as this application is known as your magnifying glass. Alright, so that is the meaning of the real and virtual image respectively. Okay, so as a rule of thumb, a general pattern is first, as object move closer to lens, the image will move away from the lens. Second is, as the image move away from the lens, its size will become bigger. So that are the two characteristic of the movement. Okay, so next thing is I want to talk is the diverging lens. So how does light travel after when it enters a diverging lens? So first thing first, for diverging lens, imagine that I have an arrow here or object here. So when I draw a light ray like this, so the light ray will diverge. But of course, we know that it can diverge here, but can also diverge here. So how do I know which direction it diverge? So this will depends on the first focal point right here. So you must make use of the first focal point, right, to help you see the direction. So let me just erase here. Okay, so I use the first focal point and I draw dotted line. Okay, then I draw a solid line to form a straight line. So this is how the light ray will diverge upon hitting a diverging lens. Of course, the next thing is I draw another light ray. So I draw another light ray in this particular manner. So same thing, you use the first focal point to help you see the direction. So the direction will be right here. So that's how the light will travel . Okay, the next thing is how do I know where is the location of the image? Because converging lens will form an image, same thing as diverging lens. So diverging lens also will form an image. So the image form will be right here. So for example, I erase this first. Okay, for example, I draw an image like this. Okay, I draw a light ray through the optical center. So you can see that when I draw the light ray through the optical center, the light rays are not going to meet on the right hand side of the lens. So the only thing that you can see, right, is the intersection between the dotted line and the purple line. So this is the intersection right here. So it means that the image form will be here. And the image form will be upright, virtual, and diminish. So this is true for all types of, this is true wherever the location of the object. So means that if you go to the next one, the next object, right, the object here is between 1F and 2F. So the image form will also be the same as the first case, upright, virtual, and diminish. So this is the characteristic of your diverging lens. Summary will be the image of a converging lens will either be real or virtual. So for virtual wise, it's only applicable for magnifying glass. The other things are all real image. The second will be inverted or upright. Upright, same thing, is only applicable for magnifying glass, but inverted is the other scenario. Then last but not least, diminish or magnified. Okay, the image of a diverging lens is always virtual, upright, and diminish. So these are the three characteristics of the image of a diverging lens. Okay, so that is it for your lenses.